So let's continue with the discussion. Let's continue with the discussion on decade counters. So we have this design yesterday, and then you designed the mode 12 decade counter, mode 12 counter, not mode 12 decade counter, mode 12 counter. Mode 12, the first state is 0 and the last state is 11 in decimals, right? So the second method which we discussed, which we won't use, we mentioned this thing initially also. This is really right. The second method which we mentioned, which that's what we are going to discuss today. Okay, and we won't use that thing in our design, all those things, but okay, so but we'll use them. We'll use it for just to understand this situation, right? Doesn't list the slides, right? Okay, I'll go back like this, right? That is better. So this is the present state. You write the state diagram, state table, that is there still. Now what we make an assumption here is that we use the assumption that J3 equals K3. Someone is joining the class, right? But add I'll do it. Okay, so we make the assumption that J3 equals K3. You could copy down the earlier, state table fillings, this columns, and you could copy down this columns, and then after that we can work the copy down the columns from the earlier decade counter design, the same columns, right? If you check, that is the same. Fill it up. Whatever I have written that in bold, you don't copy this columns. You could copy from your own notes so that you won't make errors, you won't repeat the errors which I have made. I might have made. That's what. Then we will see how does this J3 equals K3 case, right? Today a lot of people have joined classes. You are writing it, I suppose. That's why I'm keeping quiet. I don't feel a bit okay today. The climate is also quite dull, right? What is done here is that I'll observe this K-map, and I'll just fill out this things, the columns which are drawn bold like this. Say I'll check this 0 don't care. 0 don't care is either 0 0 or 0 1. So that means it is 0. Just like we did for multiplexer combinational logic design using multiplexer, same pattern. 0 don't care, that is as good as 0, and 0 don't care, 0, same way. 1 don't care means that is 1. Then don't care 0, that is 0. You are not bothered about this don't care, whatever is the logic state. The don't care 1, that is 1. This is also in bold, okay. Then again coming to this side, same way. 0 don't care is 0, 1 don't care is 1, then don't care 1 is 1, 0 don't care is 0. Same way you'll fill up these things, okay. You got the idea? എങ്ങനെയാണ് ചെയ്യണമെന്ന് മനസ്സിലായോ? Did you understand what is being done? മനസ്സിലായില്ലെങ്കിൽ പറയണം കേട്ടോ. യെസ്, അത് സിമിലാരിറ്റി നോക്കും. സിമിലാരിറ്റി നോക്കിയിട്ട് ഡോൺ കെയർ 1 or 0 ആയാൽ കുഴപ്പമില്ല. അപ്പോൾ അത് 0 ഡോൺ കെയർ ആണെങ്കിൽ 0 എഴുതാം, 1 ഡോൺ കെയർ ആണെങ്കിൽ 1 എഴുതാം. ഓക്കെ, ആൻഡ് ഡോൺ കെയർ 1 ആണെങ്കിലും 1. റൈറ്റ്, ഇറ്റ് ഇസ് വാട്ട് you fill it up. Then you will so you assume that the J3 equals J equals K for all inputs. J equals K, that is the assumption. That's why we fill it up like that. Then we will draw 3 K maps instead of, not 3, 4 K maps instead of the 8 K maps we drew earlier. We'll just have 4 K maps, 4 Karnaugh maps. Okay. At the end of this class, I'll share with you a paper which I came across. This is from Indian Institute of Science. Old paper. How they, paper means it's not the newspaper, rather a technical paper which they published. I'll just share it. I just got that paper. I'll just show this thing. So the K map, draw the K map. I'll wait. When you complete K map, just put in a message, type in a message. എല്ലാവരും ചെയ്യണേ, എല്ലാവരും ഒരുമിച്ച് ചെയ്യണേ. K map വരയ്ക്കാനല്ല ഇപ്പോൾ അറിയാം. ഫ്രഷ്ലി ജോയിൻ സ്റ്റുഡൻസ്, നിങ്ങൾക്ക് K മാപ്പിൻ്റെ കാര്യം, ആ K മാപ്പിൻ്റെ ലെക്ചർ ഉണ്ട് കേട്ടോ. K മാപ്പിൻ്റെ ലെക്ചർ ഒന്ന് എടുത്ത് നോക്കണേ. ആ വീഡിയോ, അനഘ, ചിന്നു, വിൻസെൻറ്റ്, യെസ് വിൻസെൻറ്റ്, റൈറ്റ്, വിൻസെൻറ്റ്. ദെൻ ഒരാളും കൂടി ഉണ്ടല്ലോ, അഖിൽ. അത്രേ ഉള്ളൂ, ഇനിയില്ലേ ആളുകൾ? റൈറ്റ്. സോ we get the expression J3 K3 like this. You got the expression? The expression, this is, I need to mention, this is how they minimize. This is how they went on to minimize this thing. Strangely, yes, that's it. Okay, did you get the same expression? Yes, right. So that is Q3 Q0 or Q2 Q1 Q0. That is J3 K3, and J2 K2 is you see this is K. The Q3 out itself is fed back. ഇതിൻ്റെ ഔട്ട്പുട്ട്, ഈ ഫ്ലിപ്പ് ഫ്ലോപ്പിൻ്റെ ഔട്ട്പുട്ട് തന്നെ ഇൻപുട്ടിലെ എക്സ്പ്രഷനിലോട്ട് വരുന്നുണ്ട്. That's the strange thing. That's what. Then again here Q1 Q0, right? Again K1 J1, Q3 dash Q0, and J0 K0 will always be 1 because it's most cases it is 1. അങ്ങനെ തന്നെയല്ലേ കിട്ടിയത്? അങ്ങനെ തന്നെയല്ല എക്സ്പ്രഷൻ കിട്ടിയത്? Yes, we are winding up. This is the design. I have written down the other lockout protection design. I'll make the slides next day. Any padam varikku, logic diagram. Draw the logic diagram. For me, this is an easy way. I got this logic diagram from the text itself. Okay. So this is what, so that's what I mentioned. This Q3 is itself is fed back as input to this gate, this flip-flop itself, right? Again Q3 bar goes here, right? So this is a logic diagram for this method. Now when you draw the logic diagram at your convenience, make sure you draw it, but in your notebook. Now the next day we will discuss about how to design this counters or any sequential circuit, as a matter of fact, with the lockout protection. So in this case of decade counters, we had what do you say, invalid states, unused states. So unused states should be will be a problem, because when you turn on the power, if accidentally or even during the while it's counting, if it gets to some unused state, we should redirect it back to a valid state. ഇപ്പോൾ ഇതിന് ഡിസൈൻ പ്രോഗ്രസ് ചെയ്യണം എങ്ങനെയെന്ന് വെച്ചാൽ, ബാക്കിയുള്ള 6 സ്റ്റേറ്റുകളുണ്ടല്ലോ അൺയൂസ്ഡ് ആയിട്ടുള്ള, അതായത് 1010 101 1011 1100 and 111 and 1111, all those states, that is 10 to 15, ആ സ്റ്റേറ്റുകൾ ഏതെങ്കിലും ഒരു വാലിഡ് സ്റ്റേറ്റിലോട്ട് ഡയറക്റ്റ് ചെയ്യുക. പ്രസൻറ്റ് സ്റ്റേറ്റ് അതാണെങ്കിൽ നെക്സ്റ്റ് സ്റ്റേറ്റ് ഒരു വാലിഡ് സ്റ്റേറ്റ് ഇടുക. യൂഷ്വലി ഇറ്റ് ഈസ് directed to 0, the first state. Usually it is directed to 0, or you could direct it to the next valid state. You could direct it to the next valid state in the forward direction. That's also possible, that is 0. So അതാണ് അതിൻ്റെ ഡിസൈൻ്റെ ലോജിക്. Design logic is this. So next day we will discuss how to do that. Okay, we will go step by step. Meantime, you could try the same design with mode 12 counters. You can assume j equals k, and you may try. Also, you can try this decade counter, synchronous counter design with the D flip-flops. D flip-flops. D flip-flop വെച്ച് ഒന്ന് ഡിസൈൻ ചെയ്ത് നോക്കണേ. D flip-flop ആണ് കൂടുതൽ യൂസ് ചെയ്യുന്ന ഒരു ഫ്ലിപ്പ്-ഫ്ലോപ്പ്. D flip-flop ആണ് VLSI സർക്യൂട്ട്സിൽ റിയലൈസ് ചെയ്യാൻ ഈസിയർ ആയിട്ടുള്ളത്. അതിനെയൊക്കെയാണ് JK ആയിട്ട് കൺവേർട്ട് ചെയ്യുന്നത് when we talk about the VLSI circuits. So I think we mentioned that in the class on conversion of flip-flops. അവിടെ മെൻഷൻ ചെയ്തായിരുന്നു. If you take those slides, you will see that. Okay, that's it.